Okay, so very warm welcome to this second day of the workshop. And there is a small announcement before I go into the workshop. First of all, I welcome all the participants. And the announcement is that according to our schedule, we had a talk on scalar category theory in the beginning. But due to some family emergencies, Professor Pathak cannot join us today. So we are not able to schedule this talk for tomorrow, and we will definitely let you know when we can organize that talk again. So in his place, I will be starting the first talk of this workshop, and I am Saptarshi Das, and I am an assistant professor in JIS Institute of Advanced Studies and Research. And the topic for today's talk will be the role of access control models in system security. So as the theme of this workshop is security, so I'm going to talk about one very important aspect of security, that is system security, and how that is enforced across organizations. We are going to have a look at that, and definitely, as we have this is a talk of only 1 hour kind of, so we won't have much time to go into the details, but please consider this as an introductory talk, and this is just to pique your interest and give you some idea about the topic and how these access control models, or what is the role of these access control models in system security. That is the main agenda for today's talk. So without further delay, I would share the presentation with you, and in between I will use the board also at some point of time. So and at that time I will switch to the board. So first of all, let us begin with the presentation. Is the screen visible for everyone?
Yes, sir.
Yes, sir.
Thank you. Okay, so as I told that the topic for today's presentation is role of access control models in system security. So first of all, this is somewhat related to the people who have already attended the previous workshop in the last month. They may find some similarities in the beginning, but today I'm going to cover each of these access control models in detail, and rather than where they're applied, I will talk about the concepts and what are the intricacies of each of these access control models. And before going into the topics, I have just started this this presentation with a picture. So you see a picture over here. So this is taken from a famous game. This picture is taken from a famous game called Elder Scrolls. So this shows a chest somewhere inside water, right? So, and why this picture I have included, the main idea behind this is the experts who are experts in system security, they sometimes tell that the easiest way or the only way to actually secure a system in your organization or at your home or at any place, the actual way of securing a system is to put it inside a box and drop it inside water. So, see, this means that no system is secure, and it's always a cat and mouse game between the adversaries and the people who are trying to protect their data. So as you can very well understand that if we drop the computer or the system inside water, we cannot work with it. So we have to develop mechanisms, we have to develop methods to protect our data from unauthorized access. Okay, so this is a common saying which goes around in the system security paradigm. So that's why I gave this example. And so let us proceed with the things. Okay, so the first thing is, what is security? Okay, so security involves a lot of things. Primarily, security involves that protection of your data from unauthorized access. That is, you don't want your data to be accessed by somebody who is not entitled to access that data. And this security is primarily based on three principles: the principles of confidentiality, integrity, and availability. And then the second question comes is, what are those? So the first thing is confidentiality. It involves non-disclosure of information. Like, say, suppose I have an information or I have a file that I want nobody else to access. So if I can enforce that particular thing inside my system, that is called confidentiality, that some data is confidential, that it is not accessed by anybody who is not authorized to access that particular piece of file or data. The second thing, which is a very primary, one of the primary concerns of security, is integrity. Integrity means the data should not be tampered with, or the files or the resources should not be tampered with. They should be present as it is inside the system. Okay, so suppose, for example, your bank balance. So it say suppose my bank balance is $200. So I would like to ensure the integrity of that particular data, that it should be 200. It shouldn't be like something less than 200. Nobody should be able to modify that data and change its original form. And the third very important concept is, this is not directly related to security, but again, as this age, this contemporary times, we have like a lot of users who are using a particular system. If it can be an offline system as well as an online system. So the main thing about this is availability, that the file should be available. Say suppose I secure a particular file which is very important to me, but again, due to some fault of my system, or maybe some method of securing that particular file, we arrive at a stage where it takes around 5 minutes to access that file. Say I have to go through many lines and many authentications and authorizations to access that file finally. So the availability of that file is violated. So this thing also needs to be kept in mind, that even after preservation of confidentiality and integrity, it should also be ensured that that file is available to the persons who are actually allowed to access that, and it should be readily available. It should not be like it is available after a long time, or it is available at certain point of time and then again it is not available. So these kind of situations are to be avoided. So this goes about availability. So these three form the primary aspects of security in any system. So again, the second question comes is, when do we call a system secure? So when do we call a system secure? That there should not be any unauthorized access. There should not be any modification to the data which is there by unauthorized people. Of course, see, modification is possible, but there should be a set of people who are authorized to perform that modification. So anybody who is not authorized shouldn't get the chance to modify that particular data. And the system, again, rather than only, this is from the system's point of view, and if we consider from the network and other point of view also, the softwares of the system should be up to date. There should be antivirus protection, etc. And other things, that physical security is also a part of system security. Like physical security, when I talk about physical security, we are not concerned about that as computer scientists, but again, physical security is also a part of system security, because by physical security I mean the locking of a room. This also is a part of system security, but we are not concerned about this as computer people. Okay, so the first thing we need to talk about is authentication and authorization. So we are going to concentrate on authorization today. So first of all, what is authentication? This is the first question. So authentication is just one way of ensuring the system, or making the system understand that it is you who is trying to access the particular system or any particular program or any particular file. So authentication, basically, when you put your username and your password, this is one way of telling the computer, telling the system that this is this person only. This is the person with the username he is claiming to be. Like, say, suppose I am Saptarshi and I put my username Saptarshi and I put my login password. So when I put my password correct, when I enter a correct password, the system understands that, okay, this is actually Saptarshi, nobody else. Okay, so this is authentication. Like, it verifies whether a user is the same one who he or she is claiming to be. And once he is authenticated, then there comes another challenge, which we are going to talk about. Because see, when we are talking about access control models, it's all about authorization. Okay, so when we are talking about authorization, authorization deals with determining that in a system, whenever one user is authenticated, say suppose I am authenticated into the system, I put my username and a correct password, and okay, now the system understands that this is Saptarshi, and then the system needs to determine that what resources I'm getting out of the system. See, when inside an organization or inside your personal computer also, there are multiple files, multiple programs, multiple documents, etc. So it is imperative that all these documents are not going to be accessed by all the users of the system. See, suppose inside this Windows environment, we can also create different users, and we can set the root user can set the admin, or root user can set the permissions of that particular user, right? So this we have to determine that who accesses what, who gets what into the system after he has authenticated himself or herself. Okay, so this part is authorization. Authorization deals with determining that what resources a particular user gets once he is authenticated into the system. So this is the basic difference between authentication and authorization. So when we are talking again, I'm repeating that when we are talking about access control models, these are mainly used for deployment or maybe enforcement of authorization inside an organization, or it may be in a single system also. So basically, access control security model, or also called access control model, is a set of access control rules. It gives you a set of rules that is independent of technology, or actually platform independent. That is platform independent. So for giving a very simple example of access control model, I can give you a very simple example that in many organizations, say suppose we have a university, every one of you is a part of, most of you are actually students, so are part of some or the other university. So in an university, say there are some rules. Okay, so these rules are not always in written format, but say suppose the students are not allowed to access the question paper before the, or except the time of the exam. Okay, so this is one rule. So these kind of rules, that who accesses what at what condition, what situation, or what context, these set of rules, these set of written or non-written or rules in human language, they form the access control policies of an organization. Okay, so these kind of policies will definitely be different from for different organizations. Okay, and these access control security models or access control models, they are found everywhere. They are found inside operating system. Like in a Linux operating system, we have user groups, and user groups definitely, as you most of you are aware, that these user groups have separate and distinct permissions, and which are set by mostly the network administrator or the system administrator. And when we talk about networks, how access control models are relevant to networks is that, say suppose we have a firewall, and firewall filters the different packets which are coming into the network by, say suppose, looking at their IP address, or looking at the contents or the header of the packet, something like that. So this also, these firewalls need some rules that they need to discard a packet based on some property or some criteria. So these criteria are the rules, these are the access control rules. So these are also relevant, these access control models are also relevant from the network point of view, and also these are relevant from the application, web server, software. So everywhere where there is like sharing of resources, like all the resources are not meant for everybody, so there is some specific distribution of resources as per user, as per corresponding user, there is a different set of resources they are going to get. In those, all those situations, we deploy access control models. Okay, so these access control models are basically used to enforce authorization inside organizational premises or organizational systems. So there are primarily four access control models. From like these people started working on access control models from, say, in the beginning, end of 1960s and beginning of 1970s. And in due course of time, as our systems have grown, the number of users of a system has grown exponentially, we have had different types of access control models. Okay, so the first access control model which was enforced, or which was proposed, was the mandatory access control model, or MAC. Then came discretionary access control models, or DAC, then role based, then attribute based. So we are going to briefly discuss each of them. And first of all, we move on to MAC, or mandatory access control. Okay, so mandatory access control model, this is an access control model which is a very strict access control model. Okay, so what happens in this model is only the system administrator has the permission or the authorization to decide that who gets what. So I will be giving you an example. So I'm okay. So just give me a second. There is some network issue, I guess. Okay. So we are first talking about mandatory access control model. So even the owners of the of particular resource or a file are not given the permission to select or determine the accesses of their own object. So I will be giving you an example. So let me just for the time being, let me just minimize these slides and I will share a board with you so that I can describe these things properly with an example. Okay. Okay, the board is visible for you. Everybody can see the board.
Yes, sir.
Oh, that's great. So the first thing we are going to discuss is the MAC model, or this stands for mandatory access control. Okay, so in this case, in this mandatory access control, if I represent this thing as this thing diagrammatically, so say suppose there is somebody, there is a user, who is this user is the system administrator. Okay, this is the system administrator, and say suppose there are other users, because see, system administrator is a specialized kind of user. Okay, so all of them are not system administrators. Say suppose we have only one system administrator inside this particular system, and there are multiple other users. Say suppose there will be other users too. So say suppose there are multiple users. Say I say there are n number of users, and say these are these are my files. These are the set of files I have. The files can be represented by a triangle or a square. This is just for the sake of representation. This is not a formal representation or anything. So these are files. These are some files we have. Say suppose this particular owner owns this particular file, and this particular owner owns also this file, and say suppose this particular owner owns these three files. Okay, so this is, say, the present status of our system we have. Now, even though this particular users owns these particular files, they don't have any control over the file. Everything about the file, that who executes the file, who shares the file, who actually accesses the file, everything is dependent on the system administrator. This system administrator actually determines everything, that who accesses what. So this is the most important entity inside a mandatory access control model. Now, see this model. See, if I trust the system administrator, this model proves to be the most secure model, because see, nobody can change the permissions to a specific object, not even the users. Okay, not even the users of the system can change any permissions to that specific object. So this method is a very constrained method, and this is a very good method actually, because see, this is a secure method. Once you trust the system administrator, or fix somebody as a system administrator who can be trusted wholeheartedly, then there is no chance of unauthorized accesses, right? So which property is enforced here? That is confidentiality. Confidentiality is enforced at this particular point of time, because nobody except the system administrator can give the access permissions and all to the other users or the other users of the system or other like guest users or something like that. Okay, so once we have this particular access control model has a problem. Say suppose this particular user, now let us consider this particular user, say this, he is absent from work for today. So say suppose this is an employee of an organization and he is absent from work and he wants this work to be completed by some of his friend. So that is kind of delegation of authority. Like delegation of authority means like he is giving the permissions which he has to another one to work in place of him. So but in this case the problem with this thing is, as nobody except the system administrator can change the permissions, now this delegation of authority cannot take place over here. Like even though this particular user owns these three objects, okay, these three files, he owns them because it is completely under his jurisdiction, but again without the intervention of the system administrator, so like this kind of a delegation cannot be performed. So this makes the system very less flexible, right? And due to this, what happens, the problem with this thing is, say suppose there is only one system administrator and say suppose there are 1000 users and say suppose 10 to the power 6 files inside this particular system. Okay, so what happens in this case is, it becomes very difficult for the system administrator to keep track of all these, because for each of the files the system administrator has to determine that who gets what. Okay, so this kind of a system is good when we are talking about very small number of people or a very small organization, say suppose 10 to 50 users kind of a thing. So once it goes beyond that, it becomes very difficult for the system administrator to um, maintain and enforce secure access control inside this situation. So to to address the shortcomings or address the bottlenecks of this kind of a system, we move on to a different kind of access control model. So we move on to something called the discretionary access control model, or DAC. So ACM stands for access control model. Okay. So we move to something called the discretionary access control model. And in this discretionary access control model, this model is basically based on access control list. Okay, so what happens in this thing is, say suppose I have an organization where I have particularly three users. Okay, say suppose I have an organization, I have three users, u1, u2 and u3. Okay, and I have certain files which are which needs to be protected from unauthorized access. These files are, say suppose f1, f2, f3, f4 and f5. So these are the 5 files I have, and say suppose there are 2 operations. So these operations are, say, read, and it is represented by R, and then there is write. Okay, so now what happens in this kind of a discretionary access control model is that for each of these objects, that is for each of the files, we have a list of accesses which are permitted on that particular object. So this is somewhere represented like this. Say suppose we have f1, the access control list is, say u1 is permitted to read this file, u2 is permitted to read this file, and u3 is permitted to write this file. Okay, so this is one access control list for this particular object f1. Okay, so this is how it works. So for each of these objects we have this access control list. Now you see one thing, so there can be another intuitive representation, mathematical representation of this thing. So that can be like this. Say suppose I have these files over here as columns. I have these 5 as columns and these users as rows. Okay, so if I draw it like this, and say suppose if we look into the first one, then for f1 Just consider this one, the first one, F1. U1 has a read permission over here, U2 has a read permission, and U3 has a write permission. So this way all the permissions are completed. And so see, suppose this access control list, we call this as an access control list. Okay, so this can be also converted to something called this, of this particular matrix form, and this is called an access control matrix. Okay, so this is an access control matrix. So this is all about discretionary access control. Now the question is, how does it clears the bottlenecks of the mandatory access control model? Now see, when we have this particular thing that for each of the files, the user, any user or the owner of that particular file can determine the access control list of that particular file. Okay, say suppose I have F1. For this file, say user 1 is the owner of this file, so user 1 can determine who has what permissions, and they can fill up the access control list or the access control matrix for this particular object. Okay, so this is all about the discretionary access control model. Now I will ask you people a question. Can somebody tell me that what may be the problem of this kind of an access control model? Like we talked about the problems in MAC, that is the mandatory access control model. So, and in discretionary access control model, what can be the problem? Anyone from the participants? Okay, so the main problem of this particular form of access control is, see, whenever I have a new user, say you new inside an organization, I have to manually check all the permissions they have over all the files. Say suppose in our organization, in this particular organization, there are say 10 to the power 6 files. Okay, now you can well imagine that, and we have 10 to the power 6 files, and if we move back a little, and there are two operations, read and write. Okay, and we have two operations. So you can well imagine that whenever a new user is, suppose this new user is introduced into the system, we have to check what permissions this new user has for all these 10 to the power 6 files, and for each of these 10 to the power 6 files we have to check two operations. So we have to check 2 into 10 to the power 6 times. Okay, so this is very hectic, right? So this is very hectic, and see, most of the times there are more than two types of operations, and definitely more than 10 to the power 6 resources inside an organization. So in such a situation, a problem is that this particular method of access control has a problem with scalability, that whenever the number of users is large, as we have seen in the previous access control model, that is the mandatory access control model, we saw that it was mostly feasible for a very small set of users. As compared to that, this is feasible for, say suppose quite a set of users. Say I can manage till 1000 users also, 1000 users or 1000 files, but beyond that it becomes very difficult to maintain this access control matrix or access control lists. Okay, so this is one of the problems of this particular method of access control. So again, after when the systems grew in size, like in say 1990s, okay, when the systems actually grew in size, because these two were the predominant access control models till 1996, these two, Mac and DAC. Mostly DAC was used, and again this these two models were the workhorse of access control models in the world till 1996. And in 1996, after like the advent of internet and other technologies, and people started, more and more people started using these computers and these systems, and the need for security also rose exponentially. At that time there was a need for a different kind of model, because the number of users, the number of objects, or the number of resources in organizations were increasing at an alarming rate. So this method, this DAC method or discretionary access control method, which utilizes access control lists or access control matrices, were not sufficient for providing secured access, and it was difficult to manage the systems. Okay, so in that, due to that, we came across a new access control model. It was proposed by Professor Ravi Sandhu in 1996. Okay, and that model, to be very frank, that model is still used in most of the organizations these days, up to these days. And also that model has a few bottlenecks, and we are trying to move on to a very advanced way of access control. But again, till now, role-based access control, the model I am talking about after this, role-based access control is the workhorse of access control models in the world. Okay, so we come to something called the role-based. So these things are also covered in the slides. So when if I share the slides with you, you can always find these things. So the third model is the role-based access control model, which was proposed first in 19. The idea was already there. Like when I talk about this model in a little bit deep, if I go into a little bit deep in this model, you will definitely understand that the idea of this model was already there. But again, it was not formalized, because when we need an access control model to be deployed across organizations, it is imperative that these things should be formalized and there should be a standard. Because see, these things, when used in financial organizations like banks and all, they need to have some standards. Otherwise, communication or sharing of resources between other different organizations comes to an halt if there is no standard. Because say suppose, by what do I mean by standard? That can be one question. That by standards I mean that, say suppose, say safety checking, or say suppose waterproofing of mobile phones, IP67 rating is there. So there should be some standard that if I have these features, then it is access control. This is role based access control. Okay, Renu Kumari has raised a hand. Okay, yes, please. Any,
सॉरी सर बाय मिस्टेक से हो गया.
uh, I didn't get you, pardon, can you please repeat?
हेलो सर.
Yes.
बोले सर बाय मिस्टेक हैंड से टच हो गया.
Okay, that's not a problem. Okay, no problem. Okay. Okay, so we are talking about role based access control. So the primary thing about role-based access control is the concept of roles. Okay. So roles, what are roles? Roles can be anything. Like if you consider a university, a role can be a student, as most of you are students. They can be a faculty. They can be some other officers. So why the concept of roles? Now, the second thing which comes to our mind is what is a role? And we call this role as a, see, this is, just give me a second. Somebody is trying to join. Yeah. I will give you the mathematical idea of it. Role is a set of permissions. Okay, so when you are thinking of a role-based access control systems, you have certain things in your hand. You have U, which is set of users. These are the set of users of a particular organization. You have R, which is a set of roles. And we are going to cover roles now. I will explain what roles basically mean. And we have P, which is a set of permissions. We have OP. I'm not writing set of every time, set of operations. And we have O, that is set of objects, or we also call them resources, which need to be protected from unauthorized access. We have these 5 things with us when we are talking about role based access control, right? So what happens over here is, rather than, see, if you consider access control models like the previous one, like DAC, in DAC what we had, I will just give you a short recap of that. We had these things. We had user 1, user 2, and say user n, and above this we had object 1, object 2, say object m. And in this matrix we had this permission, say suppose op1 operation 1 or op2, something like this. You remember, I think, from the previous, just from the previous discussion about a couple of minutes back, we have this thing. So now how does this role based access control model look like? Okay, so for this what we have over here is, u is the set of users. First of all, we design this set of roles. Okay, so what is this set of roles? See, now this R set of roles, I will write it once again. Set of roles. Say suppose we can represent this by R1, R2 to Rk. Say these are the set of k roles. Okay. So a set is represented not by this parenthesis, it will be like this. Please cancel this for the time being. So we have this set of roles, and each of these roles, that is R1, R2, so each Ri is a set of permission. So see, this is a sequential thing, is a set of permissions. And now what a permission is, again, see, suppose first of all I talked about roles, then I am talking about permissions. Okay, role is a set of permissions, and permission, how does a permission look? Say suppose I have this set of permissions, I have this set of permissions P. Okay, so P looks like this. P looks like P1, P2, say PL till PL. I have L number of permissions over here. Okay. Now, here what happens is each PI looks like this. I will give you an example from real life, then you will definitely understand better. Each PI is a two tuple or two tuple. Okay, so how does this tuple look? This contains an object and an operation. Okay, so this is very interesting. See, each permission is a object operation pair. So each permission means, say suppose I have a file and the operation is read. That means that permission is read object or read file f1. So this kind of an operation. So see, a role is a set of permissions, right? Now say suppose I have, say suppose I will give you a very simple example. Say suppose I have two roles inside an university. Say I have professor and I have student. These are the two roles. And for permissions, says these are the two roles I have in a particular university. And say there is another role. I will give you just a very simple example so that you understand. Say officer. Okay, we have these three roles inside a university. Now, suppose there are permissions like, say, suppose assignment, read. So this is one permission. Okay. Say suppose another permission is assignment, write. So that is modify actually. And say question paper, I'm writing QPR, read, and QPR, write. And say there are some financial documents, say bills, say read, and we have bills, write. We have these. Okay, so you can well understand that this part is the set of roles. I will just write it in a different color. So these are roles, and these things are permissions. So our objective in Abac is to associate these roles with a set of permissions. As I already told you that these roles are nothing but a set of permissions. Say suppose what will happen in this case is, say suppose this professor will be given the permission of like assignment, reading an assignment, this like this, say writing an assignment, reading a question paper, and writing a question paper. These four permissions are associated with this role called professor. And let us go to student. Say a student is only allowed to read assignment and read the question paper, and no modify permissions are given. And these officers are given the permissions to read and write these bills. Okay, so this is roles and this is permissions, and this thing which I did, this lines, drawing of lines, so assignment of permissions to roles, this is called, this whole thing is called PA, or permission assignment. Okay, this is called permission assignment. Now what happens is, say suppose I have in my organization, so this was permission assignment. Now say I have user 1, user 2, user 3, user 4 and user 5 in this particular organization. Say suppose I have these 5 things. Okay, now imagine that this u1 and u2 are professors and u3 and u4 are students. So suppose only u1 is professor. Say suppose u1 is professor and u2, u3, u4 are students and u5 is a officer, say suppose. Okay, now what all needs to be done is, I as rather than examining the permissions of all these objects and all the operations, all I need to do is I need to assign these users to some specific roles and they will automatically get the permissions which are associated with that particular role. So it will somewhat look like this. Say professor, this will be assigned to professor, this u3 and u2 will be assigned to student, and these 3 will be assigned to students as these 3 are students, and this one will finally be assigned to the officer. Now you see the interesting part of this thing is, say suppose I have a new user, I have a new user called u6. Okay, say I have this new user. Now what all I need to do is, see, in case of the previous access control model, like when we had DAC, then we would have needed to check the permission of this particular new user with all these things like assignment, whether he can read or write the assignment, read or write the question paper, read or write the bill. We had to check around 6 instances, right? We need to do 6 checkings, right? We need to perform 6 checkings. Now in this system we don't need to do that. We need to just assign this particular user into any of these, any one or more of these roles. Say suppose u6 is a new student, he has taken admission as a student. All I need to do is I will just assign this to a student. So there are no 6 checkings to be done in this case. So this actually solves the scalability problem of the discretionary access control models, right? So this is the beauty of this RBAC, and this is a very intuitive model, because see, I have represented everything mathematically, but again, as if you think that the concept of roles, that is the concept of designations, has always been there inside organizations from time immemorial, right? So this, as I said, that this concept was already there. The concept of roles, the concept of designations was already there in multiple organizations. But again, this is a formalization of that. Before 1996, these role-based access control models were not formalized. Okay, and again, this gives you an edge over discretionary access control models because this is more flexible. Because see, there are only 6 permissions in this case. Like I have given only 6 permissions, but in say multiple organizations, see, the main funda behind this role-based access control is the total number of permissions will be far. Actually, what is that? The total number of permissions, this P, will be far greater than the number of roles inside our organization. So this actually forms the base of RBAC. See, this is always true for each and every organization. The number of permissions, because each role will definitely have more than one permission, right? There are usually no roles in organizations where they have only one permission. So the number of permissions is far greater than the number of roles. So if we organize these permissions into roles, all we need to do is we need to check the number of roles instead of the number of permissions. So it helps in the scalability issue, addressing the scalability issue of discretionary access control models. Okay, so this was all about role-based access control. So any questions so far? Because I will be just giving you a glimpse of attribute-based access control before ending this talk. And I would like to ask you, can anybody try and explain to me that what can be a bottleneck of this particular access control model we just talked about, that is role-based access control, or RBAC, we call it RBAC. Anybody wants to take a try that what can be a problem of this particular model of access control? Okay, so I will tell you. The main problem of this access control model is, say suppose I am assigning everyone, say suppose I have a new user over here, say U7, I have this users, and he is a professor. So what I will essentially do is I will allocate this thing. And again, one thing I missed saying, that this part was called permission assignment, and this part where users are assigned to role, this part is called user assignment. Okay, so this is called UA and this is called PA, or permission assignment. And there is a very funny thing I will show you, that's the mathematical beauty of this thing. So if you mix UA and PA, you will definitely see, if you mix UA and PA, okay, say suppose you can again do this. Say you have this thing, you have three objects, assignment, you have this thing called the question paper, and you have this thing called bills. Okay, and you have, say suppose, just consider the blue users, U1, U2, U3, U4, U5, U1, U2, U3, U4, and U5. You have these 5 users. Now if you follow them, see, U1 is given read and write permission to the assignments and question papers. Okay, U1, for U1 I am saying. So for U1 it will be like, so assignment read write, question paper read write, and the student, that is U2 and U3, they are given read permissions for the assignments as well and the question papers as well, only read permissions. And U5, this is the officer, he is given read and write permissions on the bill. Okay, if I draw the lines, it will look something like this. Now, do you find any similarity between this thing and the previous access control model we talked about? So see, this is basically nothing but an access control matrix. This is nothing but an access control matrix. So see, again from this RBAC, we moved back to DAC or DAC, right? Discretionary access control. But again, rather than assigning all these elements, we can just check the number of roles and assign the users appropriately. So this actually is the same thing, but it adds a layer of abstraction in between. That layer is called roles. And from this UA, this was UA, user assignment, this was PA, permission assignment, and this access control matrix in which we arrived, this is called the UPA matrix, or the user permission assignment matrix. Okay, so we can see this is very easy to move back and forth from one access control model to another. This just adds a layer of abstraction, that is roles, inside it, and it simplifies the complexity of assignment of permissions to new users, right? So this is the beauty of this model called RBAC. Now again, there is one demerit about this, as I was talking about, that say suppose this new user is U7 and he's assigned the role of a professor. Okay, so this line, as I have drawn, this red line I'm talking about. Now the problem with that is, say suppose inside an organization, suppose all of you are part of any one or more one or other university, like most of you are part of at present. So see, there are different departments inside an organization, right? There are departments like, there can be CSE department, there can be EC department, there can be electrical department, there can be civil, mechanical, and many other departments. Now one thing should definitely come to your mind, that are all the permissions of all the professors of these different departments same? Like, it cannot happen that all the professors of the CS department have got the exactly same permissions as the professors of the EC department, right? Similarly, the students of mechanical engineering department will not have all the permissions similar to the students of the civil engineering department. So how do you address such kind of a situation using this thing? So one thing you can do is, suppose, as I was telling, that let us go back to the example. Say suppose there was this professor. So to differentiate that, we can divide this professor, this role called professor, into two parts. Say suppose professor CSE, computer science engineering, and professor EC, electronics. And say there are other departments too. Say suppose professor of electrical engineering, professor of civil engineering, and etc. There can be many more. So we can just split the roles. Okay, And similarly for student, the role of student also, we can just split the roles as per the department and as per their permissions. Now you see, if your organization is a very large organization, say suppose in large universities, there are hundreds of, like more than hundreds, like 500 or 300 of subjects and departments. Okay. And so now the problem with this thing is, this also at some point of time, see, the evolution of these access control models is like in sync with the growth of user base, or growth of the size of organizations, and growth of the number of people who are using the systems. Okay, so first we had this mandatory access control models, which were favorable for a very small number of people. Then we had discretionary access control models, which were also favorable for a little bit larger number of people. Then we came to RBAC, which is actually favorable for pretty large organization. But if the organization is very large, the number of roles will be again very large. Okay, so it will be again difficult to manage. So there will again be the scalability issue. See, the main issue is scalability. Okay, over here again. So see, there can be say 1,000 roles, 1,000 of roles this way. If I start splitting them as per their allowed accesses, so there can be maybe 1,000, 2,000 roles. So this phenomena is called, like splitting and forming too many roles. This phenomena is called role explosion. So this is one of the demerits of role-based access control, because as the number of users, active users in the system is rising day by day, it is difficult to capture all their data inside role. And another thing which I think some of you must have noticed in all these things, all these access control models we have talked about, MAC, DAC, RBAC, in this the access is identity based. Like, say suppose in case of Mac, the system administrator determines that this specific user will get access to this particular item. Okay, so this is based on the identity of that particular user. Similarly, in case of discretionary access control, so we write that, okay, so this is one file, and then this user will perform this particular operation on that. This user means the identity of that user. Okay, so that user, that particular user, this is only one and only. And again, in role-based access control, we have this thing, like we have a user, we are assigning them to specific roles. So again, all these access control models are identity based. Okay, and one problem of these models being identity based is that, say suppose I have an organization which needs to access a student's record from some university, but in my organization, say it is not an educational organization, it's not an academic facility. Okay, so in that case, the roles in my organization will not be professors, student, officers, etc. So the challenge will be to access. If I want to access some data or the student's record from a university, I don't fall inside any of these roles because I am from an outside organization. So this is another problem. See, because at this point of time, as we are moving ahead, the sharing of resources between different organizations is increasing day by day, and people are performing collaborative tasks. Like many organizations are collaborating and sharing their resources to complete a common goal, right? So in this case, in this way, the problem arises that sharing of data is always a challenge when we use RBAC or role-based access control, right? Okay, so we move on to a specific or a newer mode of access control that is called, this is the last thing I will be covering, but I won't go into the detail because I will maybe in some other seminars and other workshops, I will be talking about exclusively on this thing. So this is one of the access control models which we are going to use in future, that is attribute based access control, or this is also called ABAC, or we pronounce it as ABAC. So the main idea behind this access control is, here each user is defined by a set of attributes. Okay, and what are attributes? Attributes are a set of characteristics which define or which represent a person uniquely. Say suppose there is a student U1. Say suppose this is a student of an university. So in attribute based access control, we will have multiple data about this student. So how it will be? Say suppose there will be something called designation, then there will be something called department, then there will be something called course, then say year. So how to represent a student using these? Say suppose this U1 has designation of student, Okay, department CSE, course BTech, and say year 4. Similarly, say I have another user called U2 who is a faculty, say from ECE department. See, course and all are not applicable for faculty, so we put a dash over here. So this kind, say suppose this U1, see now these users are not known by their identities. Now we are not saying that he is a student. He is known by a set of attribute. These are called attributes. These things are called attributes. And these are called values. So each user is represented by what? An set of attribute value pairs. Okay, so why attribute value pair? The designation student is an attribute value pair. Department CSE, course BTech, year 4. So now you see the best part of this access control method is now this is not anymore identity based. Now suppose I have another university or another organization. Every access depends on what are your properties or what are your attributes rather than who you are. This system doesn't ask you that who are you. It asks you what attributes you have, what properties you have, and based on those properties you will be given certain accesses. So this problem of scalability is well addressed using this particular model of access control, right? And see, suppose as I told you that these users are represented like this, also the objects or the resources will also be like represented by this. Say I have this type, something called type, and say I have this department. Say suppose these two things I have. Say user, say object 1, it's a question paper of department CSE, and object 2, it is a question paper of department ECE. Okay, right? So these are the objects. Now you see how the access control rules are. See, access control, as I was telling in the first slides and the beginning of this talk, that these access control models are nothing but a set of rules, right? Now how are these rules constructed? I will write an access control rule for you just to show you an example. Say suppose there is a rule in, see, most of the rules are written in human languages. Okay, so I write any professor of CSE department can write, or say write means modify, question paper of CSE department. Okay, so this is a rule written in human language. We call this rules written in normal language. Okay, so these are called NLPs, or this is not natural language processing. Okay, so these are called natural language processing. Sorry, these are called natural language policies. Okay, NLPs. And all we need to do is, because see, this is a rule which any human will understand, but the computers won't understand these natural language policies, right? So we need to convert these things into something called digital policies, DPs. Okay, we convert these into DPs, or digital policies. Okay, and what happens is this thing can be represented something like this. Say suppose designation prof department CSE. So this is the see this is the user condition. Like this condition needs to be satisfied for this particular rule. This is the user condition, and there will be another object condition. What will be the object condition? Say type equal to question paper, and department equal to CSE, right? So this is the object condition. So this collectively, this whole thing, this is an Abac authorization rule. The authorization rules are written in this format. See, these are also expressed in form of attribute value pair. So suppose when this particular user U1, U2, which is a faculty in CSE, say which is a professor in CSE, or say suppose there is a user U3 which is a professor of department CSE. If he wants to access this, U3 wants to access or modify this particular file called O1, like U3 wants to access O1 and perform a write operation. If this is the access, we see this is one rule. This is one rule. Say suppose rule one. There are multiple rules. These are policies, right? The policy is a set of rules. So whenever this thing is called an access request. So whenever there is an access request like this, all we need to do is we need to check this access request with these rules. Okay, so when we check this U3, when first we check the user conditions. We first go to U3 and see U3 is a professor and of department CSE. Now you see this matches. This thing matches, right? Designation professor department CSE matches, right? So this rule is up to this user conditions are satisfied. And then we match O1, we go to O1, and in O1 we see that QPR and CSE is there. So QPR matches, CSE matches, right? So the object condition is also matching. And usually these rules have also something called the operation. Say this operation was right. After this, say this is the operation part. Okay, and then in this access of request, this is the write request, and there is also write in the rule. So this part also matches. So if that means this access request matches with rule one, and this particular access is granted to the particular user. Okay, so this is the main concept behind attribute based access control, and this is gradually finding its place in different organizations these days. And I think in future course of time, in due course of time, this will be the workhorse and it will completely replace RBAC in the next 1 or 2 decades, maybe one decade, maybe one, most probably. So this was all about attribute based access control. Okay, so this was all about a basic idea of access control models and their roles in system security, their roles in authorization, their role in protecting the data, protecting confidential data from unauthorized access. So this was the basic idea of the access control models we have in place. And now I am open to any questions that you may have. Okay, so you may ask any questions if you want. And also I will give you my email ID over here. If you have any questions, any further questions, even after this workshop, you can ping me up. You can drop me a mail. I will write my email ID in the chat box. So I have shared my email ID. So you can mail me any question if you have, or any question if you have now, you can ask me. Okay, so I think if you have any further questions, you can just drop me a mail, and I would like to now invite our next speaker, Professor Chandranath Adak, for our next talk. Professor Adak, are you there?
Yeah.
Okay,
Nice
so welcome,
Saptarshi.
welcome, Professor Adak, and it's over to you now.
So let me first share the screen.
I will just stop sharing. I will just stop sharing. Just give me a second.
So Good afternoon, everyone. Your signal for data science and analysis so this is the second day of our workshop, Part-2. I will mostly talk about data analytics, and here I will use some crime data. Here I have opened an Wikipedia page. Saptarshi, is it visible to everyone?
Yeah, the echo is gone now.
Yes.
Okay, okay, that's great.
So, is this Wikipedia page is visible to everyone? So, are you there?
Yes, sir. Yes, sir. I am there, sir.
So, is Wikipedia page visible to everyone? Analytics, this one,
Yes, sir.
Yes, sir. Yes.
and this writing pad, right up.
Yes, sir.
Okay, thank you. So, my topic is that time data analytics. So, before that, you should know what the analytics is. So, I suggest just go through this Wikipedia page by yourself. But the main thing is the first line. Analytics is the systematic computation analysis of data or statistics. And here we will use the crime data. So what the crime data is, or crime analysis, this is we use this crime data for analyzing or identifying the patterns of crime or disorder. So at first, some people may think, okay, this crime data is too much secure, but in the today's world of data analytics, most of the data are available in some government website, or if you can search over here in the Kaggle. There is a website name is kaggle.com, and here in my talk I will mostly focus for the undergrad fourth year student. If some of you from MTech or PhDs, so maybe this will be beneficial for you as well. So kaggle.com is a famous website for some data related things are there. You can find some data. So if you write crime data, so there some data set will come. So here also crime in India, these data sets are also here. If you just click over here, and this session will be interactive. Okay, if you have any question, just stop me and ask the question. So here you can download this data set, and here mostly some Excel files are there. We will process those Excel files, and here I will use this data set, these crimes in Boston. So Boston is a city in USA. So we'll use that data set. So here over here, if you download the data set, then you will have an Excel file. And how the data sets has been created? Just simply people are going to this data.boston.gov/datasets. So their data sets related to crime, all things are available publicly. So some people just put it by themselves, or a group of or a bunch of people, they are just doing this for us. And there is another famous website is Google Dataset Search. So if you go over here, dataset search.research.google.com, you just type here crime data. From here also you will find few data. So just like here crime in India, crime in Brazil. So it is also referring to the Kaggle dataset and few from others. Okay. And at first what I do, I will process the tasks over Google Colab. So it's a free ID given by Google. So you just type over here Google Colab, and I will create a new node. Just new node. And Boston is here in USA, Massachusetts. So here it is. So here what I need to, the problem statement is clear to everyone, like what are the crime data from where we are getting. So what I have done, I have downloaded that data from over here, crimes in Boston, and uploaded it in my Google Drive. So I want to access those data from my Google Drive. So what I will do, I will write a simple like English like language code, and here I use mostly the Python. So those don't know Python, don't be worried. It's very very simple. From Google Colab, import Drive. Drive means where I want to import my Google, and I will mount this one. Drive.mount / content / G drive means Google Drive. And sometimes there is some problem in mounting, so here you should write like force remount to. So here you can run this by clicking over here, or after typing you just enter shift enter. So is it visible to everyone, this ID?
Yes, sir.
Yes, it's visible, Professor Adak.
Here I forgot to put a comma. It is asking for authorization code. You just click over here and give the access to your Google Drive. So I will use from this ID. So copy this code. And here for this task, I need to import few things. So I am not going into the details of that command. Just follow this just for now as a syntax. NumPy, as we will use this thing, NumPy as NP, and we will also import pandas as PG, or and our objective is for data analytics. So what the data analytics is, it is written over here. We will analyze using like this. In some diagram we will draw and real-time analysis or meaningful patterns in data in this way. This is our objective. For that we need some visualization. For visualization, we will import this CBOM. CBOM as present, and we will also import matplotlib as well for plotting data. Plotly or py plotting. That's failed. So if you wait a few seconds, automatically it will come. So initially you just type and automatically if you forget you. So here line. And Here some advanced framework is also there. I may use this. Folium. From Folium, I will use plugins. And let's import few more things. Time permits, I may use those. Import linear model and few importing has been done. So now what I'll do, I need to read the file. So where my file is, you just click over here. Once refresh this thing, and here go here. Google Drive, G Drive, my drive, collab notebooks. I have just stored over here. How to upload the file in Google Drive? You just search by yourself. So here the file is. Yeah, here it is. Time.csv. So what I need to do, I need to copy this part. I copy that part, and for I will read that CSV file and put it into a data frame. Data frame DF it is, and PD is my this one, pandas. Or I will read that CSV file. You can read also Excel as well. So here my file is CSV. So I'm writing this. Then I will copy that. So I have already copied from here time.csv. Here. And here one more thing. I need to encode those data, whatever in my Excel file, in some format. So sometimes you need to format in Unicode, sometimes ASCII code. Here I am formatting into Latino. It's just sort of thing. Yeah. Yeah. So my data has been properly uploaded, and I have read this data and put it into the data. So you can see over here DF, that is data frame dot head. Let's check what it is. So it is showing I have 3,27,820 rows. Means this many number of records I have, and 17 columns means I have this 17 attributes. So here you can't see it properly. So for that reason, what I will do, I will just print say top 5 data. Here df.head in bracket it's 5. Now you can see it properly. So how the data looks like, at first there is some incident number. So it is, I believe that all of you know DBMS or database management system, or you have some idea of relational database. So here this incident number is the some sort of ID or primary ID, you can say. And here is offense code group, what type of offense it is. So we can see here this property laws, aircraft, this thing. And offense description is there, property laws, disturbing the peace, this thing. And here are the district number. So E18, E14. So in their place in Boston, they have such type of things. And reporting area, also they have few numbers. And shooting, NAN means not a number. So here no record is there. And here the occurred date and time. So you can see like 2018, 3rd October, and the time is like at night, 8:13. Year, here, month, day of week, hour means like when it occurred. You can fetch from here as well. And other things, other details are also here, like street, in which street it is, or latitude, longitude, and location is overall the latitude. I believe that you know what the latitude is. I am not printing all the data, so I am just df dot head 10, so top, like from the head or top, it will print 10 data. So from 0 to 9. And if we write instead of head, if you write tail, it will print from bottom 10 data. You can see like this ID is 327819. So you just check over here. If I type set, let's check. Showing me 327820 means it starts from 0 to 327819. That much row hands or records and 17 attributes or 17 number of columns. Now we'll process further. And we also check the data types of these fields, of these attributes. Attributes means this column. What is the inside number? What is the offense code data type? So simply you just write data frame, that is DF, or data types or D types. So you can check this offense code is a 64-bit integer, latitude, longitude are in float, few other things are in object. And you also, if you want, you can drop few columns as well. So here you can see in the shooting all fields are NA, means like not a number. So you can drop this column as well. So what I will do, I will drop here, then and drop it and update it into df dot drop. And give the attribute name. From here I will copy. Double inverted comma. Single or double. And axis, and if I'm on axis level, axis equal to 1. So column wise it will give. Now if we take df dot save or say df dot head, so here you can see that shooting has been done. You just check save. Now it will be 16. 16. So now there is another thing. You can rename also this column name. So here it is written offense description. I want to rename it as only description. So for that, we are equal to df of say columns. And what I will do previously it was, I'm copying from here, offense description. So offense description, now here it is colon, the new name is, and giving the name description. I will again. So previously it was offense description, now it is only description. Also, we just check the column name. You can see from here, sometimes we may require the column names. So here, just type df dot columns. Columns. Use columns. Previously it was offense description, now it is only description. And in the same way, you can also check, say, suppose you want to check set of 5 offense or incident number, offense incident. So yes, here I want to check this incident number. Here, this incident number, and from, say, I want to check, say, the starting will be 0, and I want to check that offense. So 0, 1, 2, 3. So this way you can check it. And there is another small command uh, I'm just checking this one, reporting area. In this thing, reporting area over here. And here I want to describe this thing. So what will be the output of describe? Here you will understand. So here, dot. So it is showing me overall record is count, means overall record is number, you already know. 3,27,820, and unique reporting area, like you know what is the meaning of it. Unique reporting area is 88, and there is sort of frequency associated. And in the similar way, you just want to check, like, if, like, unique date, like how many unique dates are there. So maybe there are some repetition. So let's check the unique incident date or occurred date. Overall, though, it is like overall count is this much, but unique days are, because here are like almost 3 years data, 2015, 16, 3 or 4 years data. So we will also check. So let's check. So, yeah, if you check the year, uh, 2015, 16, 17, and 18, 4 years data. One by one, you also check. You can also check by describing all. So, just want to check all the thing. So, if dot describe include all, so then you don't need to check one by one. All. Here, some statistical data is coming. So overall count is this one 327820. Here description, yeah, here also some reduced number is there because some data are say null values are there. It is the mean value or average. This is minimum one, this is the maximum one, standard deviations are their frequency. These are all. And suppose you want to check like if there are any like, not assigned, like, some field has not filled. So how you will know? You just take df.count, then you will understand overall number you know, like 327,820. So here you can check okay, this latitude and longitude, some field they are missing or in the script, some values are missing. So in this way you can understand few records are missing. Now from this data, so, so here you can see this hour, this column. Focus on this column, please. So you can see like 20th hour means like at night 8 p.m. 2019 is others at 19, then 8 a.m. morning. So in this way, there are like 3 lakhs, like 3,27,000 or 3.27 lakh data. So is it not possible for you to just go to the Excel sheet and just check like what are the like maximum instant occurs in which hours? So for that reason, we need the data analytics or data visualization thing. So we just plot those data programmatically. And the beauty of Python is you can write your own code. So here I will mostly use the inbuilt functionality, but you can later on, if time permits, so you can check. We can use our own code. So here SNS already we have import. That one is you can go over here. SNS is our C1. We have imported the C1 as SNS. So what I will do SNS dot box plot, then our x equal to EF, and I will put our. You can see like from here, like around say ninth hour, from 9 to say 18, the most incident occurs, and the average is around say 40. So using this plot, you can understand, and from this data, like average, if we go hour over here, this is your the sixth. This one is your minimum. Minimum hour was 0, and the maximum one, just check. Maximum hour is 23, and the average you just check. Average is 13.1. So in this box plot also, it is showing this. Perhaps you are seeing this middle black line. So this is 13.1. So in this way, you just check by yourself as your homework. And you can also check okay, from like 4th or from April to September or ninth month. So incident occurs mostly. So you just visualize them. Here I am just plotting the box plot, where other you can plot in the bar as well. So here on simple command, that is df plot is cut bracket 1 and value count counts and plot of bar. Here is the thing. So you can see, say, you can see it in the month of 8th month, means August, the crime was around 35,000. So over 4 years. Over 4 years, and instead of this month, you can also check using the discrete ones. It's right over here, discrete. Am I, am I audible?
Yes, Dr. Adak, you are audible.
Yes, some noise came actually. So, you just check, already check this discrete number is showing over here, E18, E14, E2, showing. So just plotting this diagram in P2 region, the most time has occurred. And this data actually over the 4 years. So we have already checked from 2015, 15, 16, 17, 18, 4 years. So if you want to check, suppose only the year 2015. So here you just write history dot log pf and year 2015. Now it is showing in the year 2015 in B2 region the crime is around, say, 8. You can design this as well. You just give some title, plot dot title, so 2015. You can see that 2015 the title has come now. Or dot x. X axis we have the district. And in the y axis, y level, we have count, count of that kind. So in this way, you just fix some levels. And you also do some pie chart. Just copy this thing over here. It's the same thing. Here it is plot dot pie. Pi. Instead of this plot dot bar, I am just plotting pie. So all these things is required when the data set is too much big. So you can check by yourself. You just go through your Excel file. So when you want to plot these things, your machine will be too much slow because the number of rows is like 3,27,000. Python is faster enough as it is. This is another advantage. This pie chart is looking small. If you fix the figure size or fixed size, like you say 10, 10, so it will be bigger. So there are many such kinds of plot. I will do few more. Then I will switch to another project like utilize it. Now I am doing what the mostly the using this crime data for some visualization, data visualization or some analysis part. But analytics or using some machine learning tasks, how the data will be useful, I am coming to this few minutes later. So location. So if you remember the table, perhaps we so in this location we have this thing. We already have latitude and longitude. We'll use this information. Now we use that. Location equal to defining this on variable location that means uh, latitude and then in the location we have already seen multiple locations are not a number. Some values are like null values. So I will drop those things. So there is one command drop and drop now in drop like uh, not applicable. Drop. So there location new location is the location dot drop now. Drop now is a function. So first location equal to location is dot stop. What I will do, I will take only where the latitude is greater than 40 and longitude is less than say minus 60. So you can see how I am choosing this threshold. You will understand when you see this data. So you can see most of the latitudes are greater than 40 and the longitude is near about minus 71. So it's near about less than minus 60. So so any problem up to this? So if you have any doubt or any question, just ask me. Then 40 is, and now I will just put as x and y as location, longitude and latitude. So x equal to my its location long and y equal to its location longitude latitude. So longitude is and what I will put some colors. Colors what I will do, I will put it random colors. So NumPy dot random I will choose random colors. And dot dot scatter. So I use scatter plot. Here my target is, I'm coming to this, what my target is. My target is plot the latitude longitude where the crimes has occurred. One, see, so here what is this? Is it coming? You can see over here. See the color. You just read by yourself. Alpha is a scalar value, is alpha blending between 0 to 1. Yes, alpha is opposite, color opposite. So here I have, if you don't understand the few functions, so these help options come. So alpha is your opposite. Say 0.5. So So here you can see this latitude, longitude, these values has come. Perhaps you remember I have showed you this Boston map. So Boston map, you just see this thing. So our map is also looking like this because the latitude, longitude we are using this one. So this has come. So you can also change the figure size. If the figure size, you just assign feed size. And we have also imported here this folium. Folium, what the folium does, it just import the realistic map. Here you can use that one as well. So then equal to folium dot map. And I'm just giving one location from where I will start. So say I'm just giving say 40. So initial position, say 42 and say minus 71. So zoom start. Start some value equity. Okay. So you can see some map is coming. Here also in this map, just check by yourself. So oh, I have reached far average. Let's we just put on this realistic value. So, just put, now I am in Boston. I have just copied one latitude longitude from the data. I am in Boston. Just zoom it out. So can play with this type of visualization. And there is one famous one that is joint plot using that seaborn SNS dot joint plot XY already we have defined over here. XY already we have taken over here. Joint plot XY. And what I will do, I will plot one X plot. So inside plot I will use X. Like instead of in the scatter plot, perhaps okay. I'm taking this figure. Size. Swap. Something I'm just checking. Just like online or everyone's new actually. Okay, now you can see I have plotted 20 into 20. So here the scattered plot you can check it is some like circular. So you, instead of the circular you can plot also hex or hex means like 6 edges. I'm showing like how it looks. Wait, oh, again, show. Can you see this like this diagram is showing like hexagonal boxes are showing, and you can also see this region is little bit dark. So dark blue is there, 42 point near about 42.36 x, and longitude is here around say 70 minus 71. Here in this region, there are more like crime hazard. This is the inside plot x, and here x and y we have plotted the bar plot. Here in the right hand side it is the latitude plot, and here in the upper side or the vertical we have plotted the longitude. So where is the maximum? It's just cross sectional. You can see it's the darker. And now suppose and few more things. Okay, what I am trying to say, like 3.27 lakhs data, you can scroll it by yourself and you can't look it properly by at a go. But suppose you want to check how many motor vehicle accident response are there, how many verbal dispute cases are there, how many auto theft incidents are there, or perhaps you want to check like top top few few crimes of in Boston. So suppose you want to check top 5 crimes in Boston. Then what I will do, BF this one, offense code group or value counts, then it will show me all the fields. So here few dots are coming. So I want to check say top 5. So here I just dot counts dot head. Top 5 is top one is motor vehicle accident. So the cases has been reported 38,134 over the last 4. So in this way you just check. So suppose you want to check say top 10. This way you just look, so you can analyze the data by yourself. So here one data set I am showing you, you can check like other data set, time related data set is not only this. Some banking data set are also there, some bank defaulters or the loan defaulters. Those data sets are also available. At the beginning of this session, I have showed you how to search those data. And here also you just plot the bar plots. So what I will do, I will just copy this thing, but plot bar. So, so, so it is showing me, you can see that motor vehicle response, it is the top one. It is near about 38,000. So already value we know like 30,000. But here the overlapping. So what already I have told earlier, you just make the figure size big, not say figure, say figure size, say 15. So now you can check motor vehicle action response, it is this much. So this way you just plot the data easily and very quickly using this. Okay, now my first part of this talk has been finished. I will just start and I will take another few minutes for my next one. So using this data, how this crime data may be useful to other cases, like in real estate cases. So up to this, any doubt with anyone? Otherwise, I will move to my next portion. And it's like my talk's next portion. Any doubt? Saptarshi, am I audible to everyone?
Yes, you are audible, Professor Adak. Yes.
And this whiteboard is visible to everyone? Saptarshi?
Yes, it's visible.
So here what I will do, so we are tackling with say crime data. So crime data. Obviously there should be some crime rate. So crime rate may be, there may be various things, like various way you can calculate the crime rate, like per day how many crimes are occurs in a region, or better you can think in a particular region how many or like which types of crimes are going on, shooting, vehicle properties. So based on this crime rate in a locality is a real estate pricing or real estate house price may vary. House price vary. And uh, in the banking domain as well, in the crime rate area, the bank also usually don't try to open their branches, and in the crime rate area, the house price is also getting low. So there are some usual factors are related to there. So we need to analyze this. So here what the people do, they are simply say I am just taking say only 2D data. So I have only two fields. One is a crime rate and another one is house price. So in my y-axis I have house price and here I have crime rate. Sorry, crime rate. So using this, what I will do, I will plot few data. So I am starting from say 0, 0. So when the crime rate is this much, so I am just my house price is this. And my crime rate is this. I am just plotting few data x and y axis. Okay. So so now if I want to know, so here say crime rate, say suppose something say 0. 0.1, 0.2, 0.3, this much. Okay. Suppose I want to know, okay, in some area crime rate is 0.8, and here the say house price is say, if I am talking about those Boston area, so suppose the house price is say here say $1K, say $2K, so in this way, say $8K. Here, if I want to predict if the crime rate is 0.8, what is the house price? So this is my known data. What are the ash color dots? These are my known data. Already I know this thing. And here, suppose I want to predict when this is 0.8, what will be? The house price will be this or this or this. So for these cases, I will use some machine learning technique. So those undergrad student those don't know this machine learning, please don't need to worry. Those theoretical part, like okay, if any upcoming workshop, if I get time, I will come to that. But for just for the hands-on session, you just get to know one terminology, that is linear regression. So this is very easy. So if your crime rate is 0.8, you want to know what is your house price. What is your house price? So suppose you want to put this dot over here, over here, over here. Your machine will tell you which one is the correct. So what it tries to do, it tries to draw a line over here. So based on this data, it is not like hand-drawn data. So the machine will predict. So okay, so this one straight line, because it is a linear combination. So it will do, it will just go over here and plot this data, and it will check. Okay, this y-axis. Okay, the price is, the house price is near about 8.2 $. This will predict. So few points you need to know. At first, you have few known data. So this we are calling as train. So train data means like you have some experience. Okay, this region, some house price is this much. This is a lower development area, or crime rate is too much high, or this area the crime rate is low. Okay, this price maybe crime rate low, this price may be high. So those things is few known data. Now you want to test it on unknown. So I am just telling in a very novice term. This one. So now what you are doing, you are checking only based on only one x-axis data, that is crime rate. But it may also possible, okay, this area has not that good schools are there, not that much shopping mall is there. Big shopping mall or say theater or some swimming pools are not there. So they are or good hotels are not there. So in that area, house price decrease. So at first, what I told, based on crime rate, you are predict some house price. Now I am giving this name as feature. It's a one fancy name. Those don't know. Okay, colleagues one fancy name. Okay, feature or characteristic. Only one feature I am predicting the price. Now I have multiple features. Say I have crime data. Sorry, crime rate. From the crime data, I have calculated the crime rate. Then say if the availability of say school, or say some pollution rate of that area. So those things, some say hotels, good hotels. So there are multiple things. Based on this, I want to predict the house price. Now that is we can plot this many. So if the previously we have one feature, now we have one, two, three, four features. So if we have say perhaps we have say hundreds of feature, we can plot it and we can show you. So what we will do, we will just convert it into 2D or in some dimensionality reduction. So those are some few advanced techniques. So suppose I have few features. Based on that, I have few training data and I want to test or unknown. So what is this requirement? So suppose you want to buy a price in some location, you want to say predict. Okay, based on few features. And you have provided you have some training. This will part. So here for this thing, one famous data is Boston housing data. So here, so at first I am loading the data, then I am coming. What is the data? For that, I have already uploaded there. So I'm just copying few things. The problem statement is clear to everyone? Any doubt? Any doubt? Just unmute yourself and ask me what I am trying to do. Anyone? Any question? Anyone? So, yeah, here it is. BostonHousing.csv. So this is also on CSV file. Now just take df dot add say 10. So now check by yourself what it is. So here CRIM means crime rate. Okay, crime rate obviously it is from 0 to 1. So 1 means like too much, and the highest crime is 0 means the lowest. And ZN index, there are this many features. So just count prime to LSTAT, it is feature. And MEDV, it is median value. Median value of your house price. So why it is 24? Because it is 24 means $24,000. 24 into 1,000. So it is given in the dataset description. So I am coming to the dataset description now. The crime, it is per capita crime rate by town. ZN means proportion of residential land zone for lots over 25,000 square feet. So this is we are calling is the this data characteristics, or here we can say it's as a feature. In the machine learning terminology, we call it as feature. So there is also age, proportion of the owner occupied units built prior to 1940. So this one. And MEDV, it's median value owner occupied homes in $1,000. So here we want to predict like what is the house price based on the given those feature values. Those feature means from this crime to health. From crime rate, we can also only using the crime, we can also predict this value, but it's better we have more features. So here also say NOx means nitrogen oxide emission in this area. We can say some sort of pollution. So let's count or without counting, I'm just going to say. We have got say it's overall 506 rows are there, means 506 records are there, and 14 these 14 attributes. So among these 14 attributes, 13 will be our feature, and on this last column will be our target, or we want to predict that. So that's the basic or the inside view of that linear regression. That one is linear regression. Theoretically you have to understand, but here, for the sake of simplicity, this hands-on session, I am not going into details in the theory. What those are interested, it is already in last year we had a workshop. There is completely one regression analysis is there, so you can check our like YouTube channel. So there is already. So for that we need to split the data set into what I was trying to say here, training and testing. I need to split the data set into training and testing. Means few data you have to know, and based on that data, whatever you know, you will test on the unknown data set. But whatever we have, we will just split, say 70% data we will train and 30% we will test or say validate. So this data set is clear to everyone. That is important. For this hands-on session, it is important you should understand this data. And then what is the problem objective? Your input is this feature, and you want to predict this output is median value. So this is your problem objective. Based on you have few things. So here I am randomly splitting the training and test using the 70% and for 30%, say 70% training and 30% testing. And randomly I will split. So for that, from scikit-learn, what I will do, I will import the model selection, import, and then test split, which is important for training testing split. So here x equal to ef dot I log or I location. This thing and coming 0 to 30 means 0 to 12. So 0th to 12th row it will take. Dot say values and y will be on that last column, that median value. Df it is already showing dot values. So x and y I have fixed. Now I will so my matrix or say those Excel file, which looks like this. So there are say multiple followers, say 14 columns are there. So, 0, 1, 2, 3, 4. So what I am doing, I am just splitting this. Say 70% data is my training and 30% is for testing. 70% is how? Just calculate overall we have 506 rows, so 506 into 70%. So those many I have training data. This will be my this portion 0 to 13th one. So this will be my X train. This lower portion will be my X test, and only one column, this will be my Y train. So that means for the X train data, I know the value, and I want to predict this Y test data. So this is my main objective. I want to predict what is the median value of this portion. Okay. So this is clear. What is X train? What is X test? Y train? Y test. So this thing is my target one. Y means that is my target. And this one is my that what I told feature. Okay. Those who are not understanding, when we have more machine learning related class, then those theory may be clear. But for now, so in this conversation, so explain, then express, y train, y test, this variable name, and define, then this thing I have input, and overall x and y. There you can see x, y I have. Then test size I am taking 30%. Here how I have to give, say 0.3 means 30%. And we need to define for any random things, we need to define one seed. Based on that, or it is pseudo random number. Based on that, my random number will generate. So you are from computer science, where I believe that you know what's the random number is. My system, actually this is not exactly random. My system times getting as a seed. So here I am fixing the seed as a 42. Not anything in this. Any random number. So this data set, you just make it clear just once more. Then this my data taking things has been done. So now just one line of code I write. Or before that I check like size. Print of say explain space. Say save. So everything save I save. That was like save of the size. Yeah, you can check that 354. So means 354, 150. So here we had 354 number of rows. Here how much? 152. 152 rows I have. 354 records, 152 records for testing. 354 for training, 152 for testing. Here I have 13. So it is also showing me it's 13. 354 into 13, 152. And here 54 comma means 1. Only 1. That means this one. Only this one. So 354 comma 1. Only one column is there. 152. So this has come now. And you just check by yourself 506 into 0.3, how much it is. You can see like 151.79. So if you round off this thing, so this will be 150. So my case size is, I have already defined 0.3. So you just take by yours. You can choose 0.2, but obviously the case size should be lesser than 10 size. So for that model, here I will use linear regression. Linear regression I use. So obviously, I need to import it from somewhere using some library, or I can write it by myself. Let's use the model. What now I will use. So my linear model LM is linear regression square. Then I need to feed those data. LM dot feed. It means I am feeding the data into my system. So what I will feed? Explain and YT. Explain and Y3 I will feed. Now I need to just check that. So here what I will do, I just lm dot ready f dot that one I location from 1 to 30 I log and let's see. Pin. Yeah, it is showing nicely. Let's see. If say predicted median, our target was to find the predicted one. Predicted median value is this one, and our actual one was here dot distance. Now I just print f top 10 I am just. Okay, you can see that the actual or original median value was 24, and it is predicting around say 30. Or here you can see it is the original was 22.9. Now it is predicting say 22.87. Sometimes it is here say 18.9 and it has predicted say 18.5. So obviously there should some performance measure how my system it has worked. So in linear regression there is one part you can check like many error function is there like, but I don't want to name those things. Theory part. But say for sake of simplicity, there is one performance measure in linear regression is called R square, R square coefficient. You just take, so for the best model, R square should be 1. There are some theoretical evidence. For the best model, R square should be 1. So let's check what is the R square value of our model. So for that, what you will just do, you just check by lm.score based on the test data set, x test and y test. So this will print your R square. Oh, x test is not. Yeah, x test I have put x test here the underscore was not. The R square is 0.71, so it is not 1. So if it was 1, then our model is too much accurate. Exactly. So that's why you can see like sometimes it is 28.98, it is predicting, but actually it's 33. But sometimes, but here few cases like this is working out. But there are say around, what is the number of data, 506. So you just check like, okay, check it's 200. Now check like, oh, it's not coming. You can check it is 28.7, our predicted is 25. So our actually it is 17.5, but it is showing 16. So our model is this, the R square, or our model's R square value that the performance measure is 1. When it is 1, then when R square is 1, our model is the best one. Here it is not 1, so that's why our model is not the best. We need to train our system. There's many techniques how to make your system. So up to this is okay. I have almost I have finished the things, and one more takeaway. Takeaway is there is matplotly this functionality. So there are various ways you can plot your data. So there are many ways to plot your data. Go through yourself these things, this tutorial, and just click over here. This thing, I'm just giving you the links of these data sets. Boston housing dataset based on those crime data, and I have used this crimes in Boston, this dataset. And if you want this Python, this notebook, this code, I will share it to you as well. It is this one. You can also visit our website, check what we are doing, what's our area of research here. It's academics and the Center for Data Science. So here you can check like, so this is our courses. We are teaching MTechs and diploma in data science, and these programs are there. And there are a few research areas where faculty members are working on. So if you want to connect with us for your final year project or study MTech or any type of internship, you just contact with us. You can check the faculty profiles as well. And last thing, this R square. This formula is written here if you are interested. Just go through this Wikipedia page or just drop an email to me. Want to understand that behind theory. And yeah, this line. I forgot to plot this line. Let's plot it. So okay. So I'm just plotting how it looks. So I will plot the scatter plot. I just saw this scatter. So to remember this one, just I was just plotting these lines. So in programmatically, I can also plot this. Okay. So after seeing this, I just F predicted one. This is the so but this circles are looks bigger, so you can define the circle size as well. So let's basically say one the circle size the radius. Ideas or diagram you just it's too small. This plot is showing. So if you can also define the X level, Y level, the title, those already I got it like in earlier diagram. So plot say X level. Is your X level is your like median value, the actual one. Or here I am just actual say price or median value. The Y level it's your predicted. Now where is the line? So I should plot this line. So as shown in this picture, this line. So it is showing in this direction. Our system. So there is some also theoretical. So so plot that line. For plotting that line from C-bond, I need to use the C-bond function. X axis it says it's an S dot regression plot, REG plot. Where and say okay, let's second predicted one. Then data is a frame. Yeah, it's the line has come, but all thing has in blue. I want to change it. Suppose some different line color and KWS, which is color, if I say color, which I want to get here. So now it is showing. But you can see it properly. Let's plot size. How this line has come. So you can see some shadow is there. So the range of this line, some error component, machine learning now we call it schedule. I'm not going into the details. So the dark red color is your that regression. So whenever some what is some new median values. So, okay. Any doubt? Any doubt? Any question? Any suggestion? Comment? Anyone? Okay, Saptarshi, I am done. So still, anyone have any question?
Thank you, Dr. Adak, for this wonderful presentation, wonderful session on this analysis of crime data. And I would like to request the participants whether they have any questions or not, they can come forward with their questions if they have any. Or again, I would like to mention that you can always reach to us using on our emails. And if you have any questions, we are open to questions.
The next speaker is present, Saptarshi.
We will take, at this moment, we will take a 5 minutes break. And then the last talk will be given by Professor Abhishek Ray. He will be speaking on RSA algorithm, a sneak peek into RSA algorithm in cryptography. We will take a short 5 minutes break if there are no questions anymore. So we can take a 5 minutes break and we will join at 4:55 exactly. We will be back at 4:55 with our last talk for today. And once again, I would like to thank Professor Rado for this wonderful talk. And we are taking a 5 minutes break now. So I welcome all of you back after our short break of 5 minutes. And for the last talk of today's workshop, we have with us Professor Abhishek Ray, who will be talking on, who is an assistant professor in JIS Institute of Advanced Studies and Research, and he will be talking on RSA algorithm, a sneak peek into RSA algorithm in cryptography. So without further delay, I request Professor Ray to start his talk.
Thank you, Saptarshi.
Thank you.
Am I audible?
Yes, you are perfectly audible.
Okay, so I will share my screen and I will like to know from you whether it's visible or not.
Sure. Yeah, it is visible.
Okay, and I also shall start my whiteboard.
Yes, the whiteboard is visible too.
As well. Okay, thank you. So I shall start.
Sure.
So, students, good evening. Myself, Abhishek Ray. I am an assistant professor here in the JISISR, and as for my background goes, I did my BStat and MStat from the Indian Statistical Institute, Kolkata. So I am a basically stats guy. After that, I were in the corporate sector for 2 years, mainly handling projects on data science. After that, I joined here in order to shift to academics and do my researches on different topics of data science, statistics, cryptography, finance, social network analysis, and things like that. So today's presentation will be on the RSA algorithm. The RSA algorithm is one of the most popular algorithms of public key cryptography. Public key cryptography. We will see what all these terms mean. And as for a short intro on the RSA algorithm, it was developed back in 1977, and back then it had created a lot of stir in the cryptography community, in the number theory community around the world. So this RSA algorithm has its roots in number theory, and I think some of the students here today, they also attended my first presentation on elementary number theory. So I want to mention that in the 20th century, there were two main events in the field of number theory. One was this RSA algorithm in 1977, the formulation of it. And the another one was the solution of the 400-year-old problem by Andrew Wiles. Some of you may be knowing the Fermat's last theorem, FLT. It was open for almost 400 to 450 years, and it was solved in 1993 or 94, if I'm not wrong. So these were the two great events in number theory in the past century. Now, without much ado, let's start with our presentation today. So cryptography, if we study the history of cryptography and the development of cryptography over the ages, right from the classical period, then to the Middle Ages, after that the Renaissance, the post-Renaissance period, the period of the Industrial Revolution, up to the World War II, and then the modern cryptography. One thing we will see that in the earlier ages, cryptography was a very simplistic branch, not even of mathematics. It was a branch studied mostly by laymen, because sophistication wasn't there in terms of the tools used in cryptography. Simple encryption and decryption, that was what cryptographers studied back then. From the classical period, then through the Middle Ages. And as we know, during the Renaissance, human thought had undergone a rapid change, particularly in the Europe, in arts and sciences, painting, literature, mathematics, everywhere where we saw this thing. And even Leonardo da Vinci, who was a whatnot, everything, artist, painter, scientist, anatomist. He was a cryptographer also, you may be knowing. And his form of cryptography was writing his own diary in the in a format such that when you hold it in front of the mirror, it will appear to you in the proper formulation. So that was his method of cryptography. But still, until the recent modern era, the use of number theory and combinatorics was not a prevalent theme in cryptography. So, as you can see here, the history of cryptography begins thousands of years ago. Until recent decades, it has been the story of what might be called the classical cryptography. So, though in the timeline, classical cryptography is at the very beginning, and after that we have the other eras, medieval, Renaissance, and then up to World War II. But in relation with sophistication, I will like to mention that from classical cryptography up till World War II, things were quite simplistic. And then after World War II, things began to change, and the Cold War in those days between USSR and USA, and fears and anxieties over that data could be lost from one party to the other party, to the other camp, that led to the development of the modern tools and techniques and the use of number theory and combinatorics in this field. Okay. So, who is this gentleman? As you can see, you can read from the slide. This is Godfrey Harold Hardy, one of the foremost British mathematicians of the 20th century, who did great deal of work in number theory. And we Indians are indebted to him in another way. He was the man who discovered Ramanujan. And the story goes that Ramanujan, while he was in Chennai, had written some letters to this gentleman. And after reading those letters, G.H. Hardy sponsored the entire trip of Srinivasa Ramanujan to England, and then was the patron of Srinivasa Ramanujan. And now we have many papers, brilliant papers in combinatorics, algebra, number theory, which bear the joint names of Hardy and Ramanujan. So those are joint papers. So he had a very famous quote that I will read the quote first. It goes like this: the real mathematics of the real mathematicians, the mathematics of Fermat and Euler and Gauss and Abel and Riemann, is almost wholly useless. So you see, Godfrey Harold Hardy was a gentleman from the pre-war era, pre-World War II era. And back then, cryptography didn't use these techniques of number theory and combinatorics. Neither did any other field of human endeavor considerably using mathematics from great superstars like this: Riemann, Euler, Fermat, Gauss. So these are names of great and big mathematicians of whom Hardy was a great fan. And he professed the idea that mathematics should be useless, pure mathematics particularly should be useless in order to have that flavor of a real good branch of human study and endeavor. So that was his idea, that mathematics which has some use in the day-to-day affairs of human affairs or human activities is not that much interesting as the abstract and high-end mathematics. And these mathematicians like Fermat, Euler, Gauss, Abel, and Riemann, according to Hardy, had done some work which in itself is very interesting and is more interesting because they are useless. So their beauty that lies in them is solely because of the techniques used by these great stalwarts, not because of the use that it had found in the different arenas of human endeavor. So this was the opinion of G.H. Hardy. But he was proved wrong. Why he was proved wrong? Because this was the pre-World War II era. After the World War II, different human endeavors was finding applications of different theorems in pure mathematics and even theorems in number theory. And particularly, combinatorics found interesting applications of number theoretic concepts from Leonhard Euler. So this is the same Euler as Hardy is mentioning prior to the World War II era. And after the World War II, the same Euler's Cotient function, which we will study in a short while, has impacted profoundly the development of cryptography and particularly the RSA crypto system, which we will be studying today. So what is the Euler's function? The Euler's Cotient function. If n is a positive integer, then the phi function counts the positive integers less than or equal to n that are relatively prime to n. So let's say we are calculating for 10 and the symbol that we use for the totient is the phi. So let us open the whiteboard. If n is equal to 10, we have to calculate phi 10. How much is this? Isn't it? So let us start. What is the definition of phi 10? Number of integers less than 10 which are co-prime or relatively prime to 10. That means that it does not have a factor in common with 10. So we can begin with 1 because 1 is prime to any number, because the only factor common between 1 and say 10 is 1 itself. So 1 is prime to 10. Now 2 is not prime to 10, but 3 is prime to 10. 4 is not prime to 10 because 2 is a common factor. 5 is not. 6 is not. 7. 8 is not. 9. So 4 is the number of integers less than 10 who are prime to 10. So phi 10 will be 4. Is that okay? Getting back to the slide. It's also mentioned that the Cotient function, that is phi of a prime number, is 1 less than the prime number. So phi p is p minus 1. Why is that? For example, if we just take 13 being a prime, everything, each and every integer less than 13 will be prime to 13, isn't it? So if n is equal to 13, then phi n is equal to 12. That's quite simple. Okay. Now, my question to you all. What is the Cotient function for the product of two primes? What is the Cotient function or the Euler's phi function for the product of two primes? I would like you all to find it out yourselves or work it work this as a part of your homework, you may say. I am just mentioning the result of this question. So if n, say n is the product of two primes, n is the product of two primes, p into q, and p is also a prime and q is also a prime. So the only factors of n are p and q. Then the totient function phi of n is nothing but p minus 1 multiplied with q minus 1. So you can now see the analogy, or the analogy with a single parameter, that is the totient function of a prime p is p minus 1, isn't it? And also totient function of a prime q is q minus 1. We saw that right now. So phi n, if n is pq, I am telling that it is p minus 1 into q minus 1. That means phi p into phi q. This property is known as multiplicative property. Why? Because phi p into q, if p and q are primes, is getting split into phi p into phi q. This is the multiplicative property, and this happens because of this formula. Let us verify. Let us verify whether this really happens. So let us take say 15. So is 15 a multiple of two prime numbers? It is indeed, isn't it? 3 into 5. So according to our formula, what must be phi 15? Which is phi p into 5. It will be 3 minus 1 into 5 minus 1. So it is 2 into 4, that is 8. Isn't it? Now let us verify, let us check whether that is indeed the case. Then we can trust on the formula, have a trust on the formula, because I am not proving the formula here in the presentation. So 15. So what are the integers co-prime to 15 and who are also less than 15? So 1, of course, to start with, then 2, but not 3, then 4, not 5, not 6, because 6 is divisible by 3 and 15 is also divisible by 3. Then 7, 8, not 9, not 10, 11, not 12, because 15 is divisible by 3, 12 is also divisible by 3. So 13 and then 14. So 1, 2, 3, 4, 5, 6, 7, 8. Total number is 8. It matches. So now we can trust the formula. Any question up till this point? So the totient function for the product of two primes is nothing but the product of p minus 1 and q minus 1, where p and q were the original prime numbers. We will see how, with the knowledge of all this, we will be able to tackle the RSA algorithm. Now, what is public key cryptography? I touched upon this in my previous lecture. So public key cryptography is a kind of cryptography where there are two types of keys. So you must be knowing that there are some terminologies associated with cryptography. One is encryption, this thing encryption. Another one is decryption, and of course this message which is called the encrypted message. So say this fellow Bob here wants to encrypt the message hello Alice. He will encrypt, and this will be the encrypted message. But no one will be able to understand this encrypted message except Alice, because he has his private key. This private key is only provided to Alice, so he will decrypt, and the decrypted message is what Bob had intended to write, which is greeting Alice, hello Alice. So each individual have two kind of keys. One is the public key and one is the private key. What is the public key used for? Public key is used for encryption and the private key is used for decryption. So say today we have we are 45 odd men and women attending this seminar, this presentation. It may be that we are all supplied with one public key and one private key. So each one of us will be able to encrypt a message. But say I am intending a message for Saptarshi. So after encryption, although the encrypted thing will be available to each one of you, but the private key being available to only Saptarshi, he will be only able to understand what I am communicating. Maybe say hello Saptarshi, like that. So this is the basic funda of public key cryptography. So the public key cryptography was an open problem over a long period of time. After World War II, it had surfaced in the diplomatic circles, whether it is able to encrypt our message so that only party holders, parties with particular privilege can encrypt them. And the debate was going on. And ultimately, these people, RSA, Rivest, Shamir and Adelman, did achieve the breakthrough in 1977. So this was the first public key crypto system that was devised. And not only that, till this date, it is one of the most sophisticated and popular public key crypto systems in use till today. Okay. Now, I hope you remember what congruence is, which I touched upon in my first presentation, but never mind, I will just again revise that part. So what is congruence? Say A congruent B mod M. What does this mean? This means nothing but that M divides A minus B. So we can say that 27 congruent 17 mod 5, isn't it? Because 27 minus 17 is 10 and 5 divides 10. Not only that, the other way around also, meaning that 17 congruent 27 mod 5. Because now 17 minus 27 is equal to minus 10 and 5 divides minus 10. It may be negative, it doesn't matter. 5 does divide minus 10. It doesn't leave about a remainder. Okay, so this is the meaning of the congruence notation. So let us get back. Okay. Now we come to the RSA. So a public key crypto system must be such that encryption is easy, but the decryption is difficult. Anyone can encrypt, but decryption is only meant for those with the private key. So the encryption part must be easy and the decryption part must be difficult. Okay. So we must have a mathematical relation where both these aspects are represented. One aspect must be easy and the other aspect must be difficult, and that is captured in this slide. You may not be able to grasp the whole material that has been written in this slide, but never worry, we will go into the details in the coming few slides. First, read it once. I will give you just 30 seconds. Read it once. Okay, so what does that say? It says a basic principle behind RSA is the observation that it is practical to find three positive integers, very large positive integers, E, D, and N, such that this happens, whatever it may be. The point is, even though we can find, so in this congruence, there are how many quantities are involved, how many unknowns are involved? M, E, D, and N. So there are 4 quantities involved, isn't it? The thing is that given M, number theorists say that we can calculate E, D, and N. But given the other 3 integers, we cannot calculate this D. It is very difficult to find this D. Even we know M, say M equal to say 23. It cannot be 23. Of course, you have seen here that they are very large. But say M is 23, E is 17, N is 15, like that. But from the knowledge of that, we cannot calculate D. So now from here you can understand that this difficulty is taking care of the decryption aspect of the algorithm, and that we can find easily. Given this M, we can find easily the other integers E, D, and N. That is accounts for the encryption part of the algorithm. We will go straight to the 5 main steps and see how the principle that has been mentioned in this slide is actually worked out. So to some of you, this slide may appear a little difficult, a little tricky, and to some of you it will appear very familiar. To those to whom it is appearing a little difficult, for them I will invite them to the 5 main steps of the algorithm. Not only them, but the entire those who are listening to this presentation. So the first step, yes, it is as simple as that. The first step is choosing 2 distinct prime numbers, P and Q. One can do that easily, but practically we have to choose this P and Q very high. But that also can be done with the help of a computer, isn't it? Say we want a 240-digit prime number. Nowadays computer softwares are there to help us out with the problem. So the step 1 is choosing 2 distinct prime numbers. Distinct means they can't be equal, P and Q. Second step, computing their product. So if the primes are small in magnitude, say 3 and 5, you just calculate 15. It's not so simple, but for a computer it will be simple. Say multiplying 2 very big prime numbers. It may be difficult for us, but not for a calculator. And having said that there are only 5 steps, you are in step 2 now. We are in step 2. So we are almost halfway through our algorithm. Step 3. Compute lambda n. Well, lambda is the Euler's totient function. That can also be done, isn't it? So now I ask, the thing that we learned in the beginning of our presentation, what is the totient function for the product of 2 primes? What was the answer? The answer was that if P and Q are 2 primes and n equal to PQ, the totient function will be P minus 1 into Q minus 1. Do you remember? So now this n is PQ. So what will be this lambda n?
P minus,
P minus
into
1
Q minus
into
1.
Q minus 1. Right. So that is also as easy as a pi, if you know the number theory in background. Choose an integer e which is less than that totient function and which is co-prime to that totient function. That can also be done, because given any integer, there will be integers which are less than that, less than it, and co-prime to that, co-prime to it. So there will be some e, an integer e, which is less than the totient function and which is co-prime to the totient function. As of now, just make a note of the steps, what the steps are. After this, we will delve into the matter why the RSA algorithm uses these steps or has these steps. Okay, too easy. Now, what is this? So we have e from here, this integer, which is less than the totient function of n and co-prime to it. Step 5 is determining the modular multiplicative inverse. Don't become intimidated by the term, because this is nothing but solving the congruence d congruent e to the power 1 mod lambda n. So how to solve this one? Let us see. We will go to the whiteboard. It states d congruent e to the power minus 1 mod lambda n. Solving this is nothing but solving if and only if, this is the if and only if or equivalent symbol, if and only if de congruent 1 mod lambda n. So this lambda n is known. What is this lambda n? P minus 1 into Q minus 1. Why? Because n was P into Q. This e is known. What is this e? Any integer less than lambda n and co-prime to lambda n. E and lambda n are co-prime. So in this congruence, say we are denoting it with the Roman numeral 1. This lambda n is known, 1 is of course a constant, and e we also know, so we can solve for t. And it is a fact that we can solve D efficiently in realistic time frames because there are efficient algorithms to do this. These are the 5 steps. Now we will explain where the encryption is associated, where the decryption is there. We will elaborate on those. But these are the 5 steps. One by one, once again. What do we do? Choosing 2 distinct prime numbers, P and Q, which are very large. As simple as that. Computing their product. Computing the totient function, which as n is P into Q, it will be P minus 1 into Q minus 1. Now E comes, the integer E comes into the picture. Choosing E. What is E? What is the characteristic of E? It is less than the totient function and co-prime to it. Solving for D from this congruence, because E is a known quantity here, N is known, that's why lambda N is known. So in this congruence, there is only one unknown, which is D, and the good news is that there are efficient algorithms to do this. So we are here now with 2 quantities, important quantities that we have calculated. One is E and one is D. This is the most important slide for today's presentation. E is released as part of the public key and D is kept secret as a private key. So this E is available to each one of us, say among 40, 50 people, and total these 3 lectures, I think more than 100. This E is available to each one of us, but D is kept secret. So this D varies from person to person. So for a particular message that is intended to a particular individual will be able to read that with the help of his D. But if it is not intended to him or her, when he tries to decrypt, he will get a gibberish, something which doesn't have a meaning. And why? We will further elaborate. The public key consists of the modulus n and the public encryption exponent E. The private key consists of the decryption exponent D, which must be kept secret. In fact, P, Q, and lambda n must also be kept secret because they can be used to calculate D. But if we don't know this factorization, P into Q of n, be very careful. If these are all kept secret, P, Q, and lambda n, all these are kept secret, then it is very difficult from just the knowledge of E and N to calculate, let alone D, to calculate lambda n. You know why? You know why? Say you are given this n. So the part of the public key, one part is the exponent E and one part is this modulus n, isn't it? So if I had known the factorization P into Q, then of course this lambda n will be P minus 1 into Q minus 1. And then we can step by step just go along. If I know this factorization n is equal to P into Q, we can calculate lambda n, P minus 1 into Q minus 1. Then we also know E here because E is the public key And so now we know E, we know lambda n, we know everything. Now we can calculate D because there are efficient algorithms to do this. So our purpose is not fulfilled. That's why this P and Q are also kept secret. And the crux is that if P and Q are not known, then it is very difficult to factorize an integer n into its prime components, and that is known as the prime factorization problem. What does the prime factorization problem tells us? That given a very big integer, a sufficiently large integer n, we won't be able to factorize the number into prime components within within a small amount of time, in a small period of time. This is the prime factorization problem. This is an open problem, which is a challenge to computer theorists and number theorists to devise algorithms. How can very big numbers, say 2,000-digit numbers, how can they be factored quickly into prime factors? So I will go back once again to the whiteboard to make this very clear. Say P and Q are known. These are known and these are very large. These are known, we know this, and these are very large. Can computer calculate the product n is equal to P into Q? It can very easily. The multiplication it can do very easily. This way, it's all right. But knowing n, factoring into the prime factors P and Q, if n is very large, say 10,000 digits, is it possible? Impossible. These are open problems. Actually, once in 7-8 years, someone with his colleagues comes along and puts forward a new factorization technique which works for particular n's, particular, not all n's. Okay, and there are prize money associated with such factorization problems. It's not like that in the lower classes we factorize 72 like 36 and not like that. So that's too difficult here to factorize n into P cross Q, and that is the main crux and the main thing which makes the RSA algorithm work. That knowing n, we cannot go to its prime factors P and Q in a considerably small amount of time. So on what does the security of the RSA algorithm depend? Calculating P and Q is almost impossible from the knowledge of n, if n is sufficiently large. Calculating P and Q, that is factoring a sufficiently large integer in a considerable amount of time, is almost impossible. And this is known as the prime factorization problem. And the difficulty of the prime factorization problem is what makes the RSA algorithm work. Because of the difficulty of the prime factorization problem, even while we know n and e, we won't be able to calculate d because we don't know the factorization P into Q of n. Only those individuals who have the exponent d will be able to decrypt, because he won't be factorizing and then applying all the steps to get to d, because he has d with him. Okay. Now, as I said, the difficulty of the prime factorization problem is what makes the RSA algorithm work. So exactly how much difficult is this? How much difficult is the prime factorization problem? It will be more convincing if we have a case study in front of us that will increase our trust in the favor of the RSA algorithm. So exactly how much difficult is this? So you just go through the slide. I won't be commenting anything. I think what has been written is enough. And yes, it's not a joke, and no pun is intended, of course, for an academic presentation. We cannot intend a pun. So, really, in 2019, when a group of mathematicians factored a 240-digit number, it utilized approximately 900 core years of computing power. So, the computer scientists here will have a better idea of what this means than me, and they will be quite startled. And so much so is the difficulty level of breaking these RSA codes that in 1991, on March 18, 1991, the RSA laboratories, the RSA laboratories is the organization and the agency which promotes the research in not only in the field of RSA, but it encourages research into computational number theory. So this part of number theory is called computational number theory because computing ability of supercomputers is a must in this field. Number theory has different branches. Number theory, we have analytical number theory, we have algebraic number theory, we have probabilistic number theory, we have elementary number theory, and now this is computational number theory. So on March 18, 1991, the RSA laboratories had put forward a challenge, which is known as the RSA factoring challenge, to encourage research into computational number theory and the practical difficulty of factoring large integers and cracking RSA keys used in cryptography. And the 2019 breakthrough was one such example of a group of mathematicians taking the RSA factoring challenge and succeeding as well. Till date, the highest prize money won for factoring an integer is $50,000. So that's that maybe not much when we speak in terms of industrialists and large scale capitalists, but in pure mathematics, this is a quite a considerable amount. And the prize money is, of course, awarded by RSA laboratories. So with this, I come to the end of my presentation. I hope you enjoyed and have gained an insight into the RSA algorithm and its importance and central role that it plays in particularly computational number theory. You can contact me with your queries and further tips for approaching this field of cryptography, and I am there for you. My mail ID goes like this: Abhishek@JISISR.org. And with that, I end my presentation.
Sir, thank you so much for wonderful presentation. Thank you, sir. Thank you.
I thank you as well. And I am open to any suggestion or any question that you may have. The next 5 minutes is devoted to that.
Thank you, Professor Abhishek, for this wonderful presentation on a sneak peek into RSA cryptography algorithm.
Thank you.
And I would like the participants to ask questions if they have any.
You can also type if you are the students. Sometimes they are shy, and undergrads particularly, so they can type in the chat box. So Akash Sharma has raised the question: what is the important role of RSA algorithm? So Akash, I just mentioned in the beginning of my um, presentation that the motive was to find a public key cryptography, a cryptography in which everyone which will have the public key, everyone will have access to the encrypted message, but only a few will be able to decrypt it. Like say in a class of 100 individuals. So we used to do that in our school days. So there is a code language for only 5 of us. So I'm speaking in a normal, say I'm speaking in a gibberish. No one is able to understand. Only those 5 are able to understand. So during the Cold War, this was the uh, need of the day to devise such security systems. And not only during the Cold War, after we moved on to the next phase of history, to till this day, security is a big issue, isn't it? Cyber security and many other security issues. So public key cryptography is very important, is a very important concept there. And the RSA crypto system was the first crypto system to be efficiently put forward the public key cryptography framework. It was the first public key cryptography, and till this date, it is the most popular public key cryptography and the most sophisticated one. So that is the importance of the RSA. I think it answers your question. Okay, thank you, Akash. And anything else? We can wait for a couple of minutes, and if there are no more questions, then I shall hand it over to Saptarshi. Okay, so you can of course contact me, mail me. I'm ready to be disturbed. And with that, I end my session. Saptarshi, you can now take over. Thank you.
Thank you, Professor Abhishek Ray, for this wonderful session on RSA cryptography, RSA algorithm. And that this marks the end of our 2-day workshop. And we will be organizing such workshops frequently in near future. So you can keep track of it on our Facebook page of JISIASR. And we are open to any kind of suggestions. Also, if you have any suggestions from all the participants, I'm asking, if you have any suggestions, you can tell us, you can write to us, you can mail us, and if you have any suggestions of topics on which we can organize some future workshops on, so you can suggest us. And again, once again, thank you for being a part of this workshop and making it successful. Thank you everyone for your participation, and I hope we will meet soon again in such workshops, and we will continue the course of our meetings in this way. And with that, I will end, and I would like, if you have any suggestions, I'm all ears. Okay, so if there are no suggestions, and you can always mail us any suggestions or any queries regarding the topics covered in this workshop. And with that, I end today's workshop, in this 2 days workshop, and please, all of you, please stay safe and have a nice day, and bye. Thank you everybody for your wonderful feedbacks. So I will be ending the meeting, ending the workshop. And I once again thank everybody for being a part of it. Thank you.